This question says calculate the acceleration for the three sections shown in the graph below. Anytime we get a question on a graph, we look at what's on the axis. In this case, the y-axis is velocity, and we should know that on a velocity time graph, the gradient gives you the acceleration. Now, on the other hand, you could take information from the graph and use the equation a equals v minus u divided by t, but we're going to do this using the gradient. So for the first section, which goes between 0 and 16 meters per second, we make a little right angle triangle. The run along the x-axis here is equal to 20 seconds. Meanwhile, the rise, well, from the start here, it goes from 0 up to 16. So it is 16 meters per second. We then know that the acceleration is equal to the rise over run. So for this section, that would be 16 divided by 20, which would be 0.8. Remember, it's an acceleration, so it's meters per second squared. For the next section here, acceleration is rise over run. Now, it starts off at a velocity of 16. It finishes at a velocity of 16. That line doesn't rise, so it would just be 0 divided by a run of 40, which gives us 0 meters per second squared, which we should expect because the velocity isn't changing. Constant velocity, therefore the acceleration is 0. Next section is a little trickier, but do the same thing. Make a right angle triangle from start to finish. The run here goes from 60 to 100, so it's increased by 40 seconds. The rise from start here, 16, to finish 0, it doesn't rise at all. It really sinks by 16, so we need to put in a minus 16 meters per second. So for the third section here, we do the acceleration is rise over run. Therefore, the acceleration is equal to minus 16 divided by 40, which gives us minus 0.4 meters per second squared. What the minus sign tells us is it's not really an acceleration at all, it is a deceleration.